Hello everyone, my name is Matt Bedolf and I'm here to give you a bit of a deeper dive into one particular project, one that I've been doing over the last 6 months here in San Francisco. So I'm a software developer originally, but I've been moving more and more into hardware in a same sort of way as been talked about, a lot already this evening, that through understanding how to write a piece of code, I can now program the real world. And I think one of the things that really inspired me a couple of years ago was, how many people are familiar with the Maker's Bill of Rights? Okay, this is a really interesting document that was written by a couple of guys, Phil Terone, who was one of the original guys at O'Reilly's Make magazine and sort of Make company, and a guy called Mr. Jalopy. And it's a set of things that you should do if you're creating hardware. It says things like, it's better to be powered by USB than it is to be powered by a proprietary power controller. It's better to have real screws, maybe Torx screws, but definitely not proprietary tools required to open your device. You should have replaceable batteries, or at least preferably commodity batteries. All these things that basically make a thing hackable. And the motto of Make magazine in these early days was, if you can't open it, you don't own it. And owning something means you can change it. So let me tell you the story of how I first came into playing with this. Way back in 2006, I was absolutely incredibly lucky enough to meet Massimo Banzi, who was one of the founders of the Arduino project. He was staying with a mutual friend over Christmas, and he showed me this thing, this Arduino. I'd never played it with hardware before, really. I didn't really know how it worked. He gave me a demo, a little tutorial. And I went off to a conference a month later with this Arduino he'd given me to play with. And I went into that conference and I did a session there and I said, look, the Arduino is amazing. You have to play with this thing, learn how to work with it. It's the future. And so what we did that evening at the conference was we went to like a local, to the convenience store. We bought a remote control car, the kind that's like so cheap that it doesn't even have a radio on it. It has a wire trailing out the back and the kid has to sort of run after it using the control. But the great thing about some things with wires in them is you can snip off the middle of the wire, take those wires, attach them to an Arduino, and suddenly that thing is programmable. You've been given this interface. As Tom said, you've got the ticket to the party. You can open up and repurpose this thing. So we said, right, we're going to change this wired remote control car into a Bluetooth remote control car controlled by a tablet app with Bluetooth. So we took it apart and we added batteries to it so that we could run the Arduino, and you had all the wires and so forth. By the end of the evening, we had a Bluetooth remote control car. We were so proud. It would barely move under the weight of its own batteries. But it moved, and we made it move with software, and we were software engineers, and we made this thing. So this is incredibly exciting to me. Actually, great coincidence, given what Tom was talking about. I was giving this talk a week ago at a conference for developers, and I told this story. And one of the guys who had done this hack with me was in the audience. I hadn't seen him for 7 years. We were in New Zealand when we originally did it. That guy is now owns a company that created the hardware for the ArduSat project. So he had gone from software engineering in 7 years to launching hardware into space as a result of encountering Arduino at a conference. So this is my journey. What is the most pristine Maker's Bill of Rights, rule-breaking, closed, unhackable physical device? It's a phone. Like, the phone has custom screws to open it. Everything about the inside is not replaceable. All you can do if your phone breaks is replace the entire circuit board inside. That's all they're doing in a Genius Bar or whatever. They're just replacing the entire guts. You can't break off a bit of a phone, the bit that's useful for your project, and put it into something else. The best you can do is take a phone, plug a cable into it, and then wire that into the rest of your project. So I have this company here in San Francisco, and we do product design consultancy, and we're working on our own products, physical products. And we're really interested in putting the internet into the physical world, the Internet of Things. We want phone functionality, but we don't want phones. So I built this prototype. So this is my equivalent of the remote control car. This is my telephone. And I'm going to talk a little about how I made this evening. So, some assembly required. Let's see. So what makes up a phone? So actually, when you think about it, a phone, it's this very pristine object, but it has a lot of parts, has a lot of things within it that perform different functions, whether it's memory, screen, communication, and so on. So let's have a little look at the bits you need to make your own phone completely from scratch. I mean, very high-level components, but piecing it together piece by piece yourself. So every hardware prototyping project starts with Arduino. I think, I used the Arduino Uno, like most projects do these days. It's the sort of the sweet spot of price and functionality. There are a ton of libraries out there, pretty much anything you want to work with. Someone somewhere has broken it apart, found the appropriate wires to plug into an Arduino, and written a bit of open source software that will give you software control over that thing. And as Tom was talking about, there's this, it has spawned this great ecosystem of what they call shields. Now, a shield is just something that, it's a piece of circuit board. It's the exact same size as an Arduino, and on the underside of it has these pins sticking out. And those pins are on the board in the exact place that the headers are on the Arduino board. And you just sort of squish it onto the board. Its pins go into the Arduino pins, and then it has its own set of headers on top. So you pop this on top, you sort of see the Arduino underneath there. And what this board is doing is it's adding Ethernet capability to the Arduino. So the Arduino normally, the only way it can communicate with an electronic network of any kind is by plugging into a USB cable. So you add this board, it has an Ethernet part on top, which that part has never heard of the Arduino. That part was developed for industrial applications or embedded commercial applications. But the shield sort of makes all the little connections you need to figure out how that part should connect to be controlled. And then a companion piece of software, open source software library, plugs into the Arduino environment, and suddenly you can send and receive packets of information over Ethernet. So you can start to, for example, sense data through your Arduino's sensor inputs, and then have them served up by a web server so that you can distribute that data around the internet. Another really nice, oops, went too far. Another really nice high-level part is this. This is a part called the touch shield. So what this does, it takes the a screen that's used by many hardware manufacturers to make the screen in their phone, capacitive touchscreen, very, very complicated part, incredibly complicated specification sheet. Like you read this thing, and it has certain requirements for levels of electricity, certain timing requirements. It actually has a second chip, which is a graphics chip, that talks to it and is the thing that decides what pixel goes where. And a couple of guys somewhere in the US, they had made stuff with this part before. They know all the connections you need to make. They make this shield board, which breaks out all its connections, squish it on to the Arduino board, install the software library, and now I can detect touches on a screen, and I have a full RGB, relatively low resolution screen. So you can start to make your own projects just by stacking these things together and giving your Arduino superpowers, all made from commodity parts. So my favorite shield at the moment that I've been using is a company called Seed Studio, 3 E's. They're in Shenzhen in China, and they specialize in taking designs from the community, people who've created bits of Arduino functionality, and then going to mass manufacture with them and putting them in a nice box and charging a markup and so on. So they sort of productize the, if people want to go from open source to productization, they work with these guys. So this board, I think it costs $60. I'll get back to some of the parts later. But that $60 is just to get the full prototyping board. The parts on it are actually quite a lot cheaper. But this is a GSM modem. It's basically an entire guts of a phone, all the brain of a phone, on a single board. Squish that onto the Arduino, screw on the antenna, install this software library in your Arduino environment, and you're off to the races. You can make phone calls, you can receive text messages, and so on. As I said, most of these shields, they have some core piece of functionality, which is an industrial component made by a company like Atmel and all the other ecosystem of companies we've never heard of, who make all the bits inside the things we buy. Things that are very hard to access unless you read the spec sheet, you understand the electronics of it. This is a very nice part that is exactly 1 inch across, and it implements a full stack of what you require to make a phone. Now, who's old enough to have had one of these? This is always interesting at different... Yeah, and who's geeky enough? So this is a 14.4 modem. from Hayes. Now, yeah, for the younger folks in the room, this was how we used to get on the internet. It works by phoning up your ISP and screaming at them in code. High-pitched screeching noises, horrible thing. It'll take you half a minute to download a tiny JPEG. But part of the genius of these modems that became so popular and so interchangeable, much like when the IBM PC took over the world by having a set of functionality that was fairly easy to implement and was interoperable. Hayes had this great way of talking to the modem that you plugged into your computer. It just had this command line language. You didn't need a special binary protocol to talk to the thing. It talked sort of a text code. You could connect a wire to this modem, open up a terminal window on your computer and typing things in. Things that looked like this. AT, short for attention. AT, okay, it says. ATD, a phone number. Okay, it says, and then no carrier. ATD just means attention, dial a number. No carrier means I'm not getting any dial tone. They didn't answer, they hung up. If someone calls the modem, it says ring, and it gives you a bit of metadata about it. You type ATA, attention, answer. It answers that call, says okay. ATH, attention, hang up. It hangs up the call. So you can talk back and forth with the modem, and it's controlling a regular phone line. Now, one of the great things for me about this part that I use to make my own phone is that it pretends to be essentially a Hayes modem. All you have to do to talk to it, once you've got it wired up to your Arduino, is send print statements to it, just like you would if you were debugging pretty much any code under the sun. Print AT, attention, okay, it says to me. But it's a bit higher level because it's a modern thing. It can connect to the internet. They've added HTTP capability to the thing. So instead of just saying, attention, please dial this number for me, you can say, attention, please make an HTTP connection to Google. Please open a connection to the internet using your SIM card, establish a TCP/IP session, do a DNS lookup, start talking to a website. So this 1-inch square piece of silicon can, by giving it pretty high-level commands, it can act and behave as a phone does, but it's completely separate from the phone. I've wired it to a circuit board, and it's completely under my control to play with. But as you've probably noticed, your phone is made of more than just a 1-inch square piece of silicon. You've got to see what's going on inside the phone. So to make an actual phone that I can make phone calls on, my next step was to give it a screen. Now, one of the great gifts to the world of the last 30, 40, 50 years of electronics is that certain companies and certain products have achieved near ubiquity. Like you can still today walk into a repair shop somewhere in a remote part of India with this phone, the Nokia 5110, with a broken screen, and that guy will go in a drawer, he'll pull out a replacement screen for a 5110, he'll take out screwdrivers, he'll open it up, he'll put the new board in, and your phone is good to go. And these phones keep on going forever. They're so durable and also so popular that the parts for them have basically never stopped being manufactured, even though Nokia has forgotten about it. So you can go to a nice, convenient American parts supplier targeted at hobbyists, Spark Fun, Adafruit, Makershed, and for $8, you can get the screen out of a Nokia 5110. It's this nice, easy part. It's really well understood. It's been used in tons of different applications. There's an open source library for it. The library can even do graphics. You can draw circles and lines, and it has fonts and so forth. So you get this thing, $8, squish that onto my circuit board, add it to my breadboard, my prototyping board, and now I've got the ability to talk to a SIM card with my phone, and I've got a screen. How am I going to dial numbers? I'm going to need some kind of screen, but maybe a pad or something. Well, there are a ton of home devices out there, home security things, garage door openers. The part that goes into them costs like $1. It's really well understood. Again, people have written open source drivers for how to use it. Behind each one of those buttons is just a tiny little electrical switch. There's a slightly clever way of decoding it. You may notice there are 12 buttons, but only, I think, 8 solder connections on the board. There's some clever way of basically saying, it doesn't tell you which one is being pressed, it tells you which column and which line is being pressed, and you sort of work out which key it is from that. That's really good, because one of the things you may have noticed when we've seen these pictures of Arduinos on the screen is there are not that many pins on them. Like, if I want to plug 7 separate little pins, 12 separate keys from my keypad into my Arduino, I'm going to run out. There are only 12 digital inputs on the whole thing. So what you find as you start getting into electronics is there are all kinds of incredibly clever tricks where engineers over the years have worked out how to save a pin because the part they were working with from their manufacturer had 10 inputs and they wanted to attach 12 buttons to it. So they worked out a way of making 12 buttons take 7 inputs and sort of wire the whole thing through to that. So we can benefit from these years and years of incredible simplification, driving down in price, and sort of increasing of reliability. Get these parts, find the library for them on the Arduino wiki, and drop them into your project. Now, a cell phone isn't much good if you have to walk around the city trailing power cables after you. So, it's not much. You're basically limited by the length of your power cable you can pick up from the DIY store. So, the next thing we're going to need is a battery. Because the Arduino runs off USB, anything that knows how to power a USB device will power our cell phone. So all we need, it turns out, is one of these little packs that you buy when you're going on a long trip and you're not going to be able to charge your phone. You get one of these, you charge it up, you attach it to an Arduino. It will charge, it will charge a 10-inch iPad in a couple of hours. So it will certainly keep your phone running for a good chunk of time. But things, our size is building up here, and what I'm certainly not building is a practical drop-into-your-pocket device. But what I hope you can see, by taking apart all these sort of individual atoms that make up a phone, is you could take one of these things and use it in your project. Maybe it's the battery, maybe it's the keypad, maybe it's the screen, but it stops being a phone and it starts being a collection of useful components. Just like when you write software, you might use a collection of useful components such as graphics engines, physics engines, databases. You can think of electronics components as just like that. They're just like software libraries ready to drop into your project. And that's what they look like when you code with the Arduino. So these are my parts. These are the parts to the cell phone. What do we have? So $30 for an Arduino. As we've been saying, you can get them cheaper if you look out for more compact versions, the unbranded versions, versions that are designed to plug into other circuits and so forth. We have this Seed Studio Shield. So for $60, you've got all the guts of a cell phone ready to be attached to an Arduino. Once you've worked with this, if you decide that that functionality is something you want to go to production with, then you can start looking at the components of the Shield itself. And that little SIM 900 part that is the guts of it, you can buy them one at a time for $15. And if you're buying in massive bulk, that price starts to go down and down and down. But without the Shield to prototype with, that's a surface mount component. So you'd have to use not even just the regular soldering techniques that we've seen in some of these shots of projects, but very, very sort of detailed, fine surface mount component soldering, which is something I've yet to learn myself as a software hacker. The board doesn't have an antenna built into it. And this is part of the amazing engineering of a modern phone, this pristine object. As we all know, on the iPhone, for example, the antenna is wrapped around the phone, the silver band around. But we don't have that in us, so we end up with this very sort of late 90s looking thing with a big chunky antenna sticking off the end. What else have we got? Because this part breaks out everything you need into individual connections on the board, this Shield, it has a separate connection for the microphone and for the speaker. So if you want to use like a modern hands-free headset with the earphone and the microphone on the cable, you need a little adapter that will turn the sort of the 4-pole plug that they connect with into the 2-pole plugs that the connection on the part uses. $4 for the 12-key keypad with its connections, and $8 for a screen from the Nokia 3310. And then for another $2, a piezo buzzer. So for incoming calls, you'll hear an unpleasant noise. It's not a ringtone, it's not beautiful, but it's minimal. It works. This is the minimum functionality we can get away with. And that's what they look like in the back. So as you can see, they're mostly fairly sort of pristine objects. They're ready for prototyping. They don't have complicated interfaces. They just they push together. It's a little bit more complex than working with Legos, but not very much more complex. Everything's got nice, conveniently sized, spaced apart connections that are the same spaces as the same amount of spacing as the connection between the headers on the Arduino. So it's sort of ready to connect together. And that's what it looks like. That, in its dumbest, heaviest form, is a modern cell phone broken into parts. So actually, let's see. I'm not going to go too much. There's a version of this talk where I then go into screens and screens full of code, and we talk about the operating system. But what I'll suffice to mention right now is that, in breaking down the parts, the minimal parts it requires to make a cell phone, I've just been talking about what are the bits of hardware and how do they connect together? What are the necessary parts of the physical components? But actually, every moment of every day, your phone is going through an incredibly complex sequence of decisions. Many, many things can be happening at once. And of course, a modern phone runs an operating system, just the same way as a laptop or a server. But once I'd assembled my parts of my phone, it still didn't do anything, because you've got to do the other side of every hardware prototyping project. You've got to do the software. So I'll give you a link in a second for posterity. There is a set of code for the Arduino which works with all these components. And I think one of the really fascinating things for me was just looking at what is the phone thinking when it's not doing anything? Well, it's waiting for a call. What if there's a call happening? Well, it's waiting for you to answer it or to reject it. What if you're on a call and a call comes in? Well, will it go to call waiting? Will it notify you? And you can actually start to build up this incredibly complicated flowchart of the states that the phone can go through. And so as a developer, you end up creating a finite state machine, a piece of code that goes through a series of states, depending on what's happening in the world outside. And this was the simplest possible diagram I could make of it. The phone is basically either in a call, it's ringing, or it's waiting. And that's reflected in the code that you can find at this URL on GitHub. And I guess I will be posting these slides after the talk, so don't worry about scribbling down the long URL. Now, this is for me, the scary bit. So grab a phone. Let's see what we have here. Yeah, okay. So I've got the phone here on the desk. It's plugged in. Before we go any further, let me just pop over to my Arduino environment here. Excuse me while I twist to look. So this is the phone. It's listening to me. I say AT for attention. It says OK. Let me just see how this thing goes. Here we go. There it is. It's all connected. It's working. It's on. It says ready on the screen there. So let's see if we can make this work. Sorry, just trying to find where my screen is. Okay. Someone want to call me? Anyone have a phone handy? There we go. It says ring. Excuse me. Okay, say hello. And again. There we go. And hung up. Okay, there we go. So I hope I've proved to you there. I have a fully functioning cell phone. It's made of, it's the most ridiculous Heath Robinson thing I've ever made. But I found, that in making this, as a product, I'm an engineer, but I'm a product designer. And as a product designer, it really made me think about what is a phone? What is it made from? What are the parts I can reuse? How can I break it apart? And to finish, I just want to point you at a couple of other projects that have really inspired me. I'm not the first person to try and do this by a long way, and other people have done a much more complete job. I very much did this as an experiment in could I put SIM cards into products that we might one day sell at our company? Could I make them as seamless and as magical as the way that WhisperNet works on the Kindle 3G? You don't even need to know that there's this capability inside the device. You don't know whether it's AT&T or Sprint. You don't even need to care whether it's 3G or something else. It just sort of works. And so I'm very interested in that. It's like, can I repurpose 3G functionality for non-phone devices? But I found that as I started to put the thing together, I just got excited about it. I was like, the day when I made my first phone call on this thing, when I actually called a friend and just said, do you want to go for a drink? I'm calling you on an Arduino. The geeky excitement of just like, I made the phone that I'm calling you on. Despite the fact that there's levels and levels of incredibly complicated silicon devices, open source hardware, and productization I had nothing to do with, I was still able to assemble this phone myself to a level where you can make a call on it. So Dave Mellis, who was actually one of the guys who was involved directly and indirectly with the original Arduino project, has gone even further. He's at MIT, I think. And he's gone as far as designing his own boards based on these parts, so getting the boards manufactured in China, and then going to a 3D printer and doing a woodcut case. And you can maybe just about see the way the case is sort of layered. It has this beautiful feel to it because it's sort of a layer of wood, a layer of a different wood, a layer of circuit board, a layer of wood, and a layer of wood. But it feels very much like a piece of craft, a piece of carpentry. Just happens to be that one of the layers in that carpentry is made of silicon and has functionality. The buttons even work by being sort of flexible wood. It just cuts the holes in the wood enough that the wood is flexible, and then uses pressure sensors on the circuit, sort of these attached directly to the circuit board to be his keys. There's another project called Arduino Phone. This actually I only just discovered about 10 days ago. This was actually created by the engineer in Shenzhen who created the shield board that I'm using for my prototype. So it's a little less elegant than the Dave Mellis phone, but it's even closer to the kind of prototyping I've done here in that it's basically just a stack of shields. So it's the Arduino, the GSM shield, and then the touchscreen shield. And then he just measured the size of them exactly, took those dimensions into a bit of 3D printing software, and printed his own case for it. So it's just completely, with just enough space for a battery inside. So people have taken this in different directions, making their own aesthetic, making their own complete device, and hopefully one day, you're going to walk into the Apple store and buy one of my devices with this embedded inside it. And I hope, this idea of, remember that if you don't open it, if you can't open it, you don't own it. If you can't take the pieces out of it and put them into your own project, then it's just a piece of junk as far as you're concerned. Being able to make your own devices from these components and stand on the shoulders of the giants that have designed and manufactured them, I find incredibly exciting. Thanks very much. Question? So let me see if I can just get the visual aid for you. So what I did in order to make it connect to the world, it's going to take a while to go through, is the thing itself. You just talk to it with these AT commands. So in fact, the software that I wrote is for the Arduino. The Arduino listens to what it says and says things to it. So it's like a conversation between two chipsets. And then the way you get it online. Sorry. There it is. The way you get it online is at the back of it, there's a SIM card socket, and I just went into T-Mobile, and I got their no contract $50 a month SIM with data. And then I put you put the SIM card in, you switch it on, and to debug it, you can just plug the thing straight into like a USB cable, more or less, and just start talking to it directly as I was doing on the screen there. Any other questions? Well, the modern hybrid. So at the moment we're a two-man company. and we are prototyping hardware designs. We don't have kind of in-house capability to design circuits and so forth. So what I see this as is we can make the thing, the big, ugly, badly made wires sticking out of it. This is what we mean, and then we can go to a partner company and say, but we need it to be 2 inches square. So we'll be using manufacturing partners and design partners.
What's your product?
It's unannounced at the moment.
What's your company?
The company is called Product Club. Product Club is the name of the company. Yeah, and we also do a quick advert. We also do product design consulting. So we spend about a third of our time working with hardware and software companies to do product development and sort of rapid prototyping of ideas. And then we plow that client money into the other 2/3 of our time, which is working on what will hopefully soon be 100% of our company time, which is our own product. Any other questions? Yeah. I recently flew to Portland to. This is the first time I've flown such a short flight with checked luggage. I was not prepared. I have a lot of friends who help teach these classes and work with this stuff. And I checked around a couple of people, and they said, no one cares about checked luggage. And if they X-ray it, it'll look like the inside of a regular piece of hardware anyway. But if you try and walk onto the plane with this in your carry-on, particularly given that it actually has a SIM card on it, so it can actually be signaled from a distance and cause electrical switches to open and close, yeah, you're probably going to end up in prison. And you may have noticed from my accent, I'm very keen not to lose my visa. Yes, that would be great PR. Yeah, I could send messages from my prison cell through my homemade phone. Okay.
Explain how this connects to, maybe that's all how does it connect to like different networks, all that.
Right, yeah, so it's all encapsulated by the chipset. So, the regular, they call it the AT command set, these Haze commands that originally were just about dialing and hanging up. The spec sheet for that is now like 200 pages long. It's everything from like send an SMS to switch to another network, like scan for networks attached to a network. Pretty much anything your phone can ever do with its SIM card, somewhere in a settings or somewhere in an SDK you've used to write code for it, there's an AT command that does the same thing. So it really is this little kind of robot servant that's listening for attention, do a thing. And sometimes it'll say to you, here's a thing. Here it will say OK, or no carrier, or incoming call. So it's really just about writing Arduino code that has a conversation with the SIM900 part. And they talk back and forth in the same way as your email client talks back and forth with your email server. They're just talking text over a little connection. Tom at the back.
So now that you've mastered this, what's your next love? What do you want to do next?
So the technology I'm most interested in now, as I said, I'm really interested in, can we make objects that don't have screens talk to each other in the most convenient way possible? And like having a SIM card inside is one way to do that. So the technology I'm most interested in right now is actually a thing called low energy Bluetooth, which is, so Bluetooth, Bluetooth is this terrible technology with all these problems, and it never works, and there's pairing, and there's stupid headsets. Yeah, so Bluetooth 4 has this bit of the spec which is was completely redesigned. It shares the same radio and the same hardware as regular Bluetooth, but it's much easier to use from a developer point of view. And it's basically just a way of talking back and forth, having a conversation over a short distance radio, and there's no pairing. You can just say, can I see anything around me? Let's talk, and then you swap data back and forth. Yep, just in the air. And it's been built into the iPhone since the iPhone 4S. It's built into most of the high-end Android phones. And so you can make, say, in the same way as I might make an embedded sensor that talks over this SIM card to things, I can scatter sensors around an environment and have my phone act almost like a sort of Geiger counter for data, scooping up that data over this Bluetooth radio. The best part about it is, to make the devices, you can get a part from a company called Nordic Semiconductor, that is about the size of your little fingernail, costs about $1, implements the entire low-energy Bluetooth spec, also has an ARM Cortex microcontroller on it, and will run on a coin cell battery for a year. And it costs $1. It's basically, if you ever see any device and it says requires iPhone 4S or newer, it's using BLE. So like the stick and find, the tile, that's the new little, the tile that you can find your stuff with. It's basically a tiny BLE microcontroller and BLE stack. Your phone just goes, can I see any tiles? And tiles go, I'm here. And they have a little chat. And it's very, very easy to use. And actually in iOS 7, there's a whole lot of extra things. There's a whole spec called iBeacon, which it's still behind the iOS 7 NDA, but the details of it, so the details aren't out in public, but it's basically a way of saying, of doing indoor location, of having it so that when you walk up to a painting in a gallery or the checkout in a store, your phone can go, yes, you are within 1 meter of beacon number 70, and it can pop up and gather some data or give you some experience. So I'm really excited about Bluetooth Low Energy because it's going to enable devices that run for a very long time on very low power that can talk to any modern smartphone and that you can manufacture and even sell in the single digit dollars. So that's my current excitement, and actually I think that's probably what will go into our first product rather than the SIM card based stuff, simply because of power consumption. Yes. Oh, they do, and there's a good one from Red Bear Lab as well. Is the one I've been prototyping with. Yeah, absolutely. Okay, I guess I should wrap it up there. I don't want to run over the clock. Thank you very much.